everyone. Welcome to the CSPI podcast. I'm here with Noor Siddiqui today. Noor, how are you doing?
Good. How are you? Awesome to be here.
Yeah, thanks for joining us. So can you tell the audience a little bit about your background?
Sure. Yeah, my background is in computer science, and I studied that at Stanford. And before Stanford, I started a company called Remedy as part of the Thiel Fellowship.
Okay, I thought for a Thiel Fellowship you have to. I thought you'd have to not go to college.
Yeah, that's totally the deal. So I didn't go to college for 2.5 years, and then ended up going after. So I sort of was a contrarian, not going, and then was a contrarian to the contrarians by just deciding to go after. So I'm very used to people disagreeing with me.
Okay, and you're also the CEO of Orchid, right?
Yeah, that's correct.
Yeah, and what do they do?
What does Orchid do?
Mm-hmm.
So Orchid, the main mission here is we want to help couples have healthy babies. And what we've done is we've developed a new type of genetic test for couples who are planning on having a child soon. So what we do is we analyze both partners' DNA and we identify the disease risk that's most likely to impact their future child's health. So we're looking for the top diseases, things like cancer, heart disease, schizophrenia, and diabetes. So the conditions that really matter to parents. And unlike most genetic tests that aren't really actionable, you can't really do anything about them. One of the options that we offer is embryo testing, which means that you can quantify the risk for each of these diseases in each embryo, and then the couple can select the healthiest embryo to implant. So our overall goal here is really to give parents peace of mind and to give every child a better chance at a healthy life.
Yeah. So you're so can you talk a little bit actually before we get to the sort of the mechanics of the business? Can you talk a little bit about the science behind it? So the genetic testing people are familiar with. There's certain diseases like Down syndrome where it's a simple binary, right? But you guys are doing something different. Can you talk a little bit about the polygenic risk scores and the science behind it?
Sure, yeah. So essentially, historically, clinical genetics has really focused on identifying these rare genetic changes that diagnose rare genetic diseases. So these are things like Huntington's or Tay-Sachs, and I kind of think about this whole category as old school genetics. And basically, what they're looking at is really small data sets and really specific monogenic. So one gene causes a disease. And the problem with old school genetics is that when you're looking at really rare variants, so if you think about hereditary cancer testing, there are these really rare variants that a really small fraction of the population has that makes you elevated risk for a certain disease. So one of the changes that's happened over the last couple of years is that now we have these data sets that are much, much larger. So we have hundreds of thousands, millions of people that have been sequenced. And what you can do with that data is that instead of just being able to tell folks who have these really rare variants that they're at elevated risk, you can tell a much larger fraction of people that they're at equivalent risk. And the way that these studies work is they're called genome-wide association studies. So you have cases, so individuals without the disease, individuals with the disease, and then you have controls, individuals without the disease, and you're looking for statistical associations, variants that are enriched in the people with the disease that are not there in the people without the disease. So when you run this genome-wide association study, you are able to develop something called a polygenic risk score. So instead of saying, okay, here's this single gene that causes you to get Tay-Sachs, you can say, here's dozens or millions of variants across your genome that give you a risk score, and that risk score corresponds to being 4 times as likely to develop the disease, 5 times as likely to develop the disease, what have you. So what's really exciting about polygenic risk scores today is that being in a high percentile for polygenic risk is equivalent to a monogenic mutation. So we're sort of seeing the marrying of both really rare genetic variation and its impact in health with here's some more common genetic variation. So polygenic risk, for example, is able to capture many more people who are at equivalent risk as monogenic mutations. Does that make sense, or did I muddle the distinction there?
I mean, it makes sense to me, but I know a little bit about this. I think for the audience, you can probably just break it down a little bit. So the idea is that for most things, right, for a lot of diseases and a lot of traits, every gene basically there's a lot of genes that go into it, right? And you can't, and it's not it's not a binary. It's like there's a score of a propensity to say have schizophrenia, right?
Yeah, exactly. So the vast majority of diseases that people care about, they're not governed by a single gene, right? So for heart disease, for schizophrenia, for diabetes, for height, for almost everything that people care about, it's not a single gene that governs whether or not you get that disease or you get that trait. For a very small fraction of diseases, things like Tay-Sachs, Down syndrome, cystic fibrosis, there is a single gene cause that's been identified. So the main advance that's happened very recently is that now, instead of just being able to diagnose these rare genetic conditions, we can now measure and quantify people's susceptibility to the diseases that are much more prevalent, like heart disease or schizophrenia.
Yeah, and so we needed we needed a huge samples sizes to do this because otherwise everything is so small you wouldn't detect the signal.
Yeah, exactly. So basically, we had to have compute get cheaper. We had to get sequencing get cheaper. We had to have these cohorts mature over many years so that we could track and say, okay, who ended up getting heart disease, who ended up getting all of these conditions. We had to marry the medical records with the sequencing data. So it just took a lot of time to aggregate all of these things. So even though the genome was sequenced so long ago, we never it just took until just a few years ago until we actually had the data that we needed for these models to get to a level where they're clinically useful.
And how accurate can you get for traits that people care about just from genetic scores?
Yeah, so you can quantify for someone, which percentile of genetic risk are you in? So are you in the 99th percentile? Are you in the 50th percentile? Are you in the first percentile? So if you're in the 99th percentile for something like heart disease, that can correspond to being 5 times the baseline average risk for the
Wow.
disease. So for most people, they when your child is born, you're like, oh, my child is in the 50th percentile for weight or the 60th percentile for weight. You're like, okay, I feel relieved. So similarly, my position is that if you are in the 99th percentile for breast cancer risk, that's also something that you want to know and that you might want to take action on. So that's why we're providing that information to parents in this setting.
Yeah, and so how does it so basically how does it work just like technically? So couples come to you, they have to go through it's in vitro fertilization, right? They need a number of embryos usually, and then you select based on the polygenic scores.
Yeah, exactly. So I guess to back up, there's sort of two products here, right? So the first product is just a saliva-based test. So you both partners spit in a tube, and then we simulate the outcome of recombination, and we tell a couple, hey, your child is expected to be normal risk for everything. Like you should just relax and have peace of mind. The other outcome
Uh,
for that couple report is, hey, you're in the 99th percentile, or you're at elevated risk for this one condition, and this is how much you could mitigate that risk if you were to create 5 embryos or 10 embryos during IVF. So it's just
right.
another data point for them to say, this disease has affected me, it affected my partner, it affected my family member, and I see that I'm at elevated genetic risk, and here's one potential mitigation action that I could take. So if they were to take that mitigation action, what it would look like is they would go through IVF, they would create embryos, and then we would sequence each of those embryos. So on day 5, an embryo is called a blastocyst. It's about 125 cells. So 5 of those cells are sampled, and those are sent to our lab, and then they're fully sequenced. So in addition to polygenic risk, there's actually a lot of other risks that you can evaluate when you have whole genome sequencing data. But yeah, for the purposes of what we're talking about, if a couple is concerned about something like schizophrenia or heart disease, they would be using a polygenic risk score to quantify the risk present in each embryo.
And before they came to you, I mean, you would presumably know something about your genetic risk because you'd know if you ever been diagnosed with schizophrenia, and you'd know if you had it in your family or heart disease or anything, right? It would be pretty. Is there? I mean, for people who have enough of large enough families to have a sample size, are there a lot of surprises in there, or that's usually pretty much what people expect?
I think it's hard to say, right? Because one thing that's really frustrating about existing genetic tests is, like, let's say your mom or your sibling has breast cancer, right? If you go to today to take a hereditary cancer panel, there's a really small number of genes that are evaluated. So just because you don't have that rare variation, that doesn't mean that there's still not a hereditary component to the disease. So that's what's exciting about a polygenic risk score, is that it can tell you, it can quantify specifically for you how high risk are you. So if my sister were to have the disease, and then I would be in the 50th percentile, then I could breathe a little bit more of a sigh of relief to say, okay, I don't actually have elevated risk. Versus if I ended up in the 99th percentile, then okay, I should be a little bit more concerned that I have an elevated genetic susceptibility to the disease. So that's what's, I guess, useful or exciting about polygenic risk as opposed to as opposed to just these rare hereditary cancer panels. So I guess to respond to your question about how often is it surprising, it's sort of, I guess, yeah, it just depends on how many siblings you have, or how closely tied you are with your family's health history. A lot of times people disguise their health history. I mean, I've been really surprised to hear that many couples who are going through our reporting, they're looking for information about, just their mother. Did their mom have a C-section? Did their mom have gestational diabetes? Did their mom have preeclampsia? Any of these other, conditions that would be useful for a daughter to know before she goes into her pregnancy, and it's just not a
Yeah.
topic that is discussed. So it's really surprising. People often are not open about things that would be very relevant to their family members.
Yeah, you're right. I mean, of course, because the siblings can have different, polygenic scores, right? That's the whole basis of what you're doing. So yeah, your family background will tell you something, but it won't. Obviously, it's much better to have the genetic data. So when people come to you, are they usually already pretty set on IVF, doing IVF for whatever reason, or are they often just getting the test and then deciding based on that?
Yeah, it's a little bit of both. I mean, that's what's so interesting about the time that we live in now is that I'm 27, and a huge number of my friends are going through egg freezing, and that wasn't as common just 5 years ago, just 10 years ago. So there's some people who are very set on doing IVF because of they already have documented infertility. There's some people who are set on doing IVF because they know they have a single gene mutation that they want to address via PGT, which is embryo screening. And there's other folks who just really want to go into their pregnancy as informed as possible, and would consider the possibility of IVF if they discovered a significant risk that they were worried about.
Yeah. How much does this all cost?
So the couple report is $1,100, and the embryo testing we haven't released yet, so I can't comment on price yet.
Okay. Oh, so the product is not available yet, or you just don't make that information public?
Yeah. So the embryo testing is going to be available in Q1 of next year, but right now it's just being used in a clinical setting at Stanford.
And you guys are the first people to do this, right? This is theoretically there's no scientific barrier here, right? We know, but we have GWAS. So we have this data. We can do IVF, and so is it right that there's no sort of scientific uncertainty? I mean, there's uncertainty obviously with everything you do, but the
Mhm.
science is solid, and you guys are just the first ones to be able to put it together and put together a business, or are there other companies doing the same thing?
Yeah, so the thing that's also pretty compelling is actually the chemistry behind it. So when you're looking at embryos and you're talking about just a handful of cells, like 5 cells, there's actually not very a lot of DNA. So if you think about blood or saliva, there's a lot more DNA in blood or saliva than in just 5 cells off of an embryo. So there's actually quite a few advances on the chemistry or the amplification side in order to be able to call a whole genome sequence off of an embryo. So that's something that we're really excited and proud of being able to introduce. And there's implications for that data beyond just polygenic risk scores. There's monogenic panels. There's structural. So basically, anything that can go wrong with a text file can go wrong with your genome, right? So you can have insertions, you can have deletions, you can have the word "the" copied way too many times. So all of those different types of genetic typos can be detected with whole genome sequencing, and that technology hasn't been applied to IVF and specifically to this problem. So yeah, we feel super honored and excited to be able to introduce that to parents in such a important moment in their lives.
Yeah. So you said that you can extract enough DNA to do the full genome sequencing with just 5 cells, and that's an innovation. Other companies can't do that.
Yeah, that's correct. As far as I know, there's no other company offering whole genome sequencing of embryos. But to be fair, we haven't released it publicly yet. It's just in a handful of clinical cases at Stanford right now. So in Q1, I'll be really excited to announce that to everyone.
Yeah. Well, that's exciting.
I just feel like honored and flattered, I guess, to be able to offer this to these families because each individual has such a compelling story and reason for why they're pursuing this type of testing. So, yeah, I guess I would say every single sign up is personally meaningful to me.
Can you talk about like sort of the demographic balance of the people coming to you? Like how many are gay couples? How many are just heterosexual couples with with concerns? How many are just single women? Do you know that, or do you keep track of that?
Um, we should keep track of that. I actually don't think that's a question in our questionnaire. Is what who's your partner and things like that. But yeah, I could add that to our questionnaire, and then maybe I'll be able to get back to you next time we chat. I actually don't know
Yeah.
those stats.
Okay, yeah, that's fascinating. Okay, cool. I mean, best of luck to you. I mean, this is amazing. How did you become interested in IVF and genetic screening and these related topics?
Yeah. So my mom has a really rare condition. It's called retinal pigmentosa. So she in her early 30s got this diagnosis that she was going to progressively go blind throughout her life. And my siblings and I were all super terrified and devastated because obviously your vision plays a huge role in your ability to be independent in your life. And my mom is sort of a fiercely independent person, and we kind of watched her lose the ability to drive, which is and but not before getting into many car accidents and being unwilling to admit that her vision actually was degrading, unfortunately. But yeah, I just grew up being super worried that this was going to affect other members of the family, that it would affect me, and then as I got older, that would affect my kids, and then as I started spending more time in genomics, I was just shocked that things had changed dramatically from where they were 10 years ago. Right now, genetics has become a computational science. It's not that you have these really small pedigree studies of just a single family or a handful of families that um, you know just a geneticist can analyze. Right now, computer scientists are actually useful. Data scientists are actually useful in order to build these models that help stratify and quantify risk for individuals. So I think that's it's sort of a very long story, but it's something genetics has interested me from a very young age because of the experience with my mom. But I wasn't lucky enough to think that there was actually a contribution that I could make until much later in my life.
Yeah, I've also been fascinated by genetics and the research. I mean, the behavioral genetics research is absolutely fascinating. And then I've just been reading. There's a book called "Who Are We" by David Reich. Have you read it?
No, no, tell me about it.
Is it called "Who Are We"? It's called. Let me see. David Reich. I'm just googling here. Yes, it is. Who we are, not who are we? Who we are and how we got here. Yeah, he's a Harvard. He's a Harvard. What does field be called? He's like an anthropologist, a biological anthropologist. And what you can do now is you can extract DNA from people who lived, 1,000 years ago, 2,000 years ago, and you could sort of you can sort of reconstruct history based on genetics now, right? So you can
Mm-hmm.
go to like a place like Hungary, and you can look at people's genetics in Hungary, and then you can look at who was living in Hungary 1,000 years ago, who was living 2,000 years ago, right? Who was living 3,000 years ago, and you could do this for every region of the world. And this is something that's new. That you needed to be able to sequence, and you needed to be able to draw just extract the DNA from these old fossils, these old remains, right? And it's absolutely fascinating. You could reconstruct sort of, like you could say the population of Europe was, replaced. 70% of them were replaced, and whatever this year, 1,000, 2,000 years ago. I think it was about. I think it was earlier than that. But there was this entire like population replacement in Europe, right? For example, you can look at the caste system in India. You can look at like the genetic basis for that. Um, and it's really cool because this is based on science apparently that's only been around for 5 or 10 years, so it's completely new. And there's these historical debates like the origins of the Indian caste system, which people would just discuss, and they rely on textual evidence, and then eventually you can have the genetic evidence from the remains, and then you could put it together and you could basically reconstruct history. So it's really really cool. Um, and yeah, it just reminds me of what you're talking about because there's so many things that stagnate. Like my background is political science. I read in the social sciences, and a lot of the stuff is just it's not like there's some cutting edge breakthrough thing 10 or 20 years ago that's like going to revolutionize the world, right? Where you look at the study of ancient history, with anything having to do with biology. So you have this intersect of like biology, computational power, right? It seems like that's where things are taking off, right? And that's what that's what Reich and his lab are doing, and that's what I think you're doing too. You're on the cutting edge of something that's that is gonna impact the world. I mean, you could just see the way things are progressing.
Yeah, I mean, that's actually what got me so excited about this problem, to be honest, because I think that there's basically right now, we're at this moment in history, which is okay, before this moment, parents had no ability to, stack the odds in their child's favor against disease, right? And then now, at this moment, there's this convergence of tools, right? Sort of the computational resources and the data is finally here. And then on the chemistry side, the amplification technology is finally there where we can actually read the DNA off of something as small as an embryo accurately, right? So it's required the convergence of so many different forces in order for things to be at the place that they're at today. And now it just feels, extremely exciting to be at this moment where parents have this fundamentally new capability that they never had before, and something that is sort of so tied to human nature, right? Which is like, I want to have my child. I want my child to have a better life. I want my child to not suffer in the same way that I did. And there's nothing more fundamental than health, and to be able to give parents that superpower is just really exciting, because for a lot of couples this is the difference between having a child and not having one, because they have so much anxiety and stress around not wanting to have a child, because if they did, they would be worried that they would have the same condition that one of the partners suffers from. So yeah, it's just really cool when you stand on the shoulders of giants and you're able to contribute something that hopefully will have a really positive impact on families.
Yeah, and I like on your website you talk about sort of the ethical considerations of this, and I think we think about this in similar ways. So can you talk about sort of the ethical objections and how you respond to them and how you see them?
Which one do you think is sort of the steel man? What do you think is the most significant one? And we can start there.
I think they're all terrible, to be honest. It's really hard for me to steel man something that I don't I guess it's something along. I mean, there's something inequality, right? And so there some people will be able to afford it or not, which okay. So let me try it. I'll make the best effort I can. Okay, there's inequality. Some people will be able to afford it while others won't. So this will lead to some classes having healthier children than others. Um, and then there's the idea that you could have, and there's an ethical concern, but then there's also an unintended consequences concern that if you select for certain things, you might get some other things that you're not selecting for. This could have larger social implications. So I guess can you talk about those, the inequality and then the unintended consequences?
Yeah, so I think for the inequality one, it's sort of it's really sad because our society is so unequal in so many different ways, right? Like, even if you just go one step back, talking about IVF, right? So we're already in a situation where people who have more means are able to have children, and people with less means aren't able to have children, right? Because infertility isn't considered a disease in the United States. It's not covered universally by insurance companies. So you're already in a situation where some people are able to afford treatment and other people aren't. So I think that's super unfortunate, and we should be working to change that, right? I mean, there's been dozens of studies that show that people who are infertile have the same psychological distress as someone who's being given a cancer diagnosis, right? I mean, it's a very significant diagnosis to receive, and we should support every one of those families who wants to have children, and it's not unusual to do that. So, for example, Israel actually offers universal IVF for any woman up until the age of 44. So it's sort of just a societal decision. We have to say, hey, we value families, we value people having disability. Other countries have chosen to do that, and we could certainly choose to do that as well. So um, I actually think that that's probably one of the most legitimate arguments, because I do think that this should be available to everyone. But unfortunately, that's just not the system that we've all chosen to agree to, right? I mean, everyone doesn't have an iPhone. Everyone doesn't have lots of things. Some that are more significant, that more significantly impact people's lives than others. So. Unfortunately, pretty much all technology starts out, pretty expensive, and then advances are made so that it can be, made more affordably and made so that everyone is able to benefit from them. But it's weird because it's also like a collective bargaining decision, right? Of like, do we value this thing as a society, and do we want to cover it like we cover breaking your leg or getting chemotherapy? So I think it's sort of interesting that basically the U.S. has chosen not to cover IVF. It's a bit surprising to me. I don't know what you think.
Yeah, so private insurance does not cover IVF usually, or it does?
Oh, it usually does not. So there's a small number of companies in the U.S. that offer fertility benefits, and it's covered as part of a employer-sponsored benefit. But the average American does not have coverage for IVF.
Yeah, so it's interesting. I mean, yeah, we do make these choices all the time. So I know that Obamacare added mental health as a requirement. Some places, I mean, some insurance did cover like things like, well, no, not mental health. I think it was rehab, right?
Mm-hmm.
So it was drug rehab. So a lot of insurances didn't cover this, and I think some people think, I don't think I'm at risk for going to rehab. So, and I think that there's actually good evidence that rehab is not all that's cracked up to be empirically. But anyways, we made the choice to cover it, and yeah, I'm interested to hear. Yeah, I was interested to know that for IVF, how expensive is IVF these days? Like, what's a? I know every place is different. What's a ballpark?
Yeah, it's kind of funny. It's kind of like saying, how much does a car cost, right? Because it's like, well, do you want a Ferrari or do you want to have a Toyota Corolla? So, but I think that the nationwide average is something around 12,000. So it's around 12,000 per cycle, which is pretty interesting because a C-section, I think the average cost in the U.S. is around 15,000. So it's like
Yeah.
it's actually, I don't know. People obviously always complain that it's very expensive, but it's actually quite affordable if you think about just like the context of a lot of other interventions in
Well,
the
that sounds
prenatal
like,
setting.
yeah, that sounds like probably because insurance doesn't cover it. I think what happens, that makes sense because things that insurance doesn't cover, people pay out of pocket. You actually have to compete on price. So maybe if we did cover it, yeah, there's all kinds of, I'm sure, as inefficiencies and weird sort of idiosyncrasies in the American healthcare system. Uh,
Yeah, absolutely. But yeah, I think that the unintended consequences, I think, is a much I would say the inequality argument, I think, is more legitimate. I'd say the unintended consequences is a little bit more grasping at straws. So basically, right now today we're already doing single gene testing on embryos. So for things like BRCA, for mutations like CHEK2. So these are adult onset predispositional genes. So that means that it's not a guarantee that if you have this gene that you're going to get the disease, even as an adult. It just means that you're 3x more likely, 4x more likely, 10x more likely to develop the disease. So we're already doing that. So to say that there's somehow more unintended consequences by using a more powerful risk score that's going to capture more people at equivalent risk, it doesn't really make sense to me, right? Anytime that you make a decision, you have to make it with the information that's available at the time, right? So today, we know that this specific genetic sequence is going to make you 5x more likely to develop, breast cancer. So, if there's some unknown, meaning there's like some other disease that it's that this embryo is actually very low risk for. I mean, how can you make a decision based on information that's not known at the time, right? If you use that logic, then you would never be able to pursue any medical intervention, right? No drug would ever be approved because you'd say, okay, well, you've studied it for 10 years, but what happens if in 50 years something that we don't know could happen, right? I mean, if that was your bar for medical intervention, then you know we would choose to have none as a society.
Yeah, and it seems like this is, as far as all medical interventions go, it seems like this is really on the safe side. All you're doing is you're taking, naturally developing embryos, right? And you're implementing them, right? That's all you're doing. It's just the fact that you're creating, five or 10. How many do you usually create in one for one couple?
Yeah, it really varies depending on the couple and the age of the woman. But yeah, getting anywhere between 5 and 20 embryos is totally within the realm of possibility. It's not crazy to have that many
Yeah.
just
So all your
just in
so
1 or 2 cycles. Yeah.
Yeah. So I guess you're just sort of maybe shifting the distribution of the population, which like happens all the time, right? I mean, the population is always, people are getting together, they're recombining genes, and then that's happening anyway, right?
Yeah, exactly. So basically, for parents, for couples where the odds are stacked against them, you're simply allowing them to revert to the mean, to say that, hey, collectively, we're more likely to have a child in this like top 5 percentile of the distribution. Why can't we, move our child to the 70th or the 50th, right? Like, why would it be okay to say let's make them make an uninformed choice rather than an informed choice? Like, so because currently you're just having a beauty contest between these embryos. You're saying, oh, which one, morphologically, which one just looks like it's going to be better, right? So why would you say that, you know, that's somehow superior than actually having the information that's currently available about the genetic risks that these embryos have?
You say they look at it before the old way is to look at it morphologically. What do they look for?
Yeah, it's kind of just embryologists look at the trophectoderm. So this is there's two parts of an embryo: the inner cell mass and then the trophectoderm. So the trophectoderm is a set of cells that will become the placenta. So I mean, I'm not an embryologist, so I probably can't speak too confidently about this, but essentially there's just normal and abnormal ways that both of these structures are supposed to look, and there's a grading system. It's called the Gartner scale, and there's a reasonable amount of agreement around, okay, this is considered an AA, this is an AB, or this is a BB, meaning AA would be the best, and that's just used to score embryos on morphologically which one looks the best.
How accurate are those ratings? I mean, how
I
accurate?
mean,
I guess I guess that's a strange question because you.
well, I guess you could measure accuracy by how much do embryologists agree on these scores, and there is, there's some level of disagreement, but usually IVF labs will try to, have the same have multiple embryologists, grade the same embryos and calibrate so that it's not like if you get one embryologist, they're going to have totally different scores than another one at the same center. But that's the issue with something that's subjective that involves just taste making by a human, is that there is obviously interoperator variability.
Yeah, I think you might be a little bit. I mean, I feel like the inequality argument. You want to steelman the opponent. I think you might give it a little too much credit because it really proves too much, right? We can decide whether to improve the healthcare of a third world country, and no one ever comes along and says, well, inequality, right? I mean, no one ever uses that as a reason to stop progress on anything. Even within our own society, like you said, iPhones, computers, whatever, Ferrari. Some people are concerned with inequality, but we don't just say this service or this good just shouldn't exist, right? We don't do that for anything. So what would be different about this?
Yeah, I mean, I'm definitely sympathetic to that. I mean, I think that I want it to be available to everyone in the long term, but of course, I wouldn't be working on this if I didn't think that in the immediate term, there's a huge amount of benefit for these families who can afford it. But I don't know. I would say of all the arguments, that's the one I'm actually most sympathetic to, because I don't know. I guess I just personally want it to be available to everyone. But I agree. I don't think it should be used as a reason to stop progress for this or for anything else.
Sure. So one other thing you talk about on the website, you talk about this as an issue of reproductive freedom, which is powerful, and it's not something. It's not a way. It's not the way I think people often think about these issues. So can you just talk about that a little bit?
Yeah, I mean, I think that people are kind of getting very activated by the idea of parents having the ability to choose which embryo they implant based on this information, and it's sort of like, well, um, that's actually much less consequential than the ability to choose your partner, right? I mean, choosing your partner has a much larger consequence than choosing your embryo, right? So it's sort of like, why would we say to parents that you have the ability to marry whoever you want, you have the ability to have children however you want, but then when it comes to choosing which embryo to implant, that's where your freedom and your ability to access information stops.
So are any regulatory barriers you guys deal with, or is it in the United States? Are you pretty much free to do what we've been talking about?
Yeah, that's what's so surprising, is that the IVF space, because it's not covered by insurance and because it's not federally funded, it's actually been a fairly self-regulated field, right? So um, yeah, I just think most people are really surprised by that there's any spaces in healthcare that exist in that way, where there's still a large cash pay population, and there's still a large this standard within the industry of self regulating, and there's not regulatory bodies. Like, for example, CLIA is an agency that handles labs, and embryo testing actually doesn't fall under CLIA, which is really surprising even to most lab directors that you talk to, because saliva samples, for example, those do fall under CLIA, but embryo samples actually don't fall under CLIA, which is it's just a surprising consequence of the fact that IVF has never been federally funded.
Well, I mean, so here's another benefit of not being covered by insurance, right? You might have
Yeah.
a lower cost, and then you have less regulation. And maybe if you want to expand it, you want the technology to progress, you want it to get cheaper, you want it to be available to as many people as possible, home and abroad. Maybe you guys should not want to be covered by insurance. Does that make sense?
Yeah. No, it is interesting. It's sort of like it's a double-edged sword. It's certainly true, right? I mean, I think if you talk to most entrepreneurs in the healthcare space, they'll say that they're extremely frustrated with insurance companies. They're extremely frustrated with how difficult it is to insert a product into the system that makes patients' lives better, makes doctors' lives better, but for whatever reason, it's not appetizing enough to the insurance company or whoever the payer is, and then it's not able to you know become part of the process in the way that there's more free competition in pretty much every other industry besides healthcare.
Are any of your customers the ones that signed up, or do you plan on having customers from abroad?
Oh, international? Oh, yeah, we love international folks. I mean, people don't realize this. Whenever they talk about the cowboys of IVF, they always think that, oh, like this is probably happening in China. But the US is actually the most forward thinking, and the place that is the fertility tourism destination for the entire world. So
Mhm.
in China, surrogacy is illegal. In
Mhm.
China, sex selection during embryo testing is illegal. And both of those things are illegal in the US. So you actually see a huge influx of fertility tourism from China, India, even parts of Europe where surrogacy is illegal. So, I think that's something that most Americans are surprised to learn, that actually, we're much more forward thinking and doing more things than China, for example.
Yeah, so I've seen survey data. It doesn't contradict that, but it's surprising in light of what you're saying, that if you survey uh, fertility specialists or doctors in the U.S. versus China and India, for example, those on China and India will be more aggressive about the necessity of selecting for good traits. Have you ever seen any data like that? Because I remember reading this.
Yeah. I do know what you're talking about. It was sort of a survey of just people's general perceptions about, would testing embryos for diseases be, a good or bad thing to do morally, and people's general perceptions of it. But so, yes, it is surprising, right? There is more support for it in India and China, but just from a regulatory perspective, their regulations are actually more lax in the US and more restrictive in those parts of the world.
Yeah, interesting. Where are you guys located? I hear you're in the office, right?
Yeah. We're based in San Francisco, and we have folks all over the country.
Uh-huh. And so, do you find that? So, we talked about sort of the people have ethical ideas. Do you think that being from an immigrant background changes your views of these things? Do you see in like your work? Do you see a difference between sort of how Americans look at these issues and how people from other countries look at them?
Yeah, I think that's interesting. I don't know. I haven't actually thought about how does the fact that I'm Pakistani impact the work. I mean, I think that the most significant thing that's impacting my perspective on this is just seeing the impact of a disease firsthand, and really not wanting to have that myself or to pass it on to my future children. So I think that that's probably the most significant impact. I think that whenever I talk to someone who has one of these diseases, or a sibling with one of these diseases, they resonate with it a lot more than people who are sort of were already, won the genetic lottery at birth, and they are super healthy and they don't have any concerns on their mind. To them, they think it's designer babies, but for people who suffer from these conditions, they're like, oh wow, this is something that would really benefit me personally, and they're they just have a very different perspective on it. I mean, I think in terms of coming from an immigrant background, I think, Steelman, one of the concerns that people raise about polygenic risk scores is that there's a lot more data on Europeans right now than on non-Europeans, and I'm also sympathetic to that issue because I obviously want want these scores to work super well on South Asians and other minorities, and I think that something that's missed in those discussions is that there's actually a huge amount of attention on that issue, right? So statistical geneticists are spending a lot of time in developing new techniques and new methods to augment the data and to make it so that these scores, even in the absence of an equal amount of data on every ancestry group, can actually still perform remarkably well. Even in the absence of data. So there's actually one company, they're called Myriad, and they have a breast cancer risk score, and they recently published results showing that it works, well across all ancestries. So we've already sort of seen wins and attention disease by disease to make sure that these scores work for everyone. And I think that that's something that perhaps I might be particularly self-interested in. That okay, there's not as much data on me personally, so I'd love to see more South Asian data, more East Asian data. I think you're Palestinian, correct?
Yeah, my dad's Palestinian, my mom's Jordanian.
Yeah, so basically, I don't know if you know this, but Middle Eastern data is actually some of the most poorly represented. I don't know why, but um, you know, it's for whatever reason we have our data sets contain. I think the least amount of data is on Middle Eastern people, and maybe then add mixed people, so basically people who are hybrids or more than that. So yeah, I think that's a super important problem. But I think that what I find most surprising about everything related to reproductive technology is just how controversial every single thing has been. I mean, birth control was fought for decades. Artificial insemination was initially denounced as a form of adultery. IVF was strongly opposed for creating test tube babies. Condoms were initially opposed, and eventually all of these practices became mainstream, and the scientists who pushed through the controversy ended up winning Nobel Prizes, talking specifically about IVF. So I think that's particularly surprising to me. Is just that, there's an enormous amount of, benefit from each of these, each of these, products that have existed inside reproductive tech, but uh, unilaterally, pretty much all of them have been, met with a huge amount of, just an initial pushback.
Yeah, I guess in historical perspective, then, I mean, the reaction to this seems pretty muted, right? There's no big Supreme Court cases. There's no big, clamoring for regulation. It seems like it's sort of like standing on the shoulder of giants, but like morally, right? It's like the reproductive freedom thing in the U.S. became established. Obviously, it's not universally accepted, but
Mhm.
it's accepted by a lot of elite and mainstream institutions. And then the new things. I mean, there's no, it's different. It's like like homosexuality is like something that's like always sort of controversial. But something like IVF, right? I don't think opposition to it is like seen as like in any way like a mainstream thing. I think because everyone sort of can imagine like themselves getting older, right?
Mhm.
And having problems. I think the fact that it's sort of like just something that happens to you often, if you're old, I think makes people sympathetic. And the fact that everyone could sympathize with the idea that you want your children to be healthy and not have diseases and have the best chance in life. And maybe that dampens. I mean, like when you poll people on this stuff, and it's like they're inconsistent. They'll say it's good to to deal with diseases. I think that'll get support, but anything that's like any kind of enhancement makes people uncomfortable. But in the real world, it's hard to draw that distinction, isn't it? I mean, like schizophrenia is a disease. Okay, what about bipolar, right? What about OCD, right? How do you think about that? Like, is there really a distinction here, or is it just sort of there's all traits, and just we just have to make choices about what we want to do.
Mhm. Yeah, I just think that the person who's most qualified to make these decisions is really the parent, right? I mean, if you lived with, heart disease, or if you live with breast cancer, if you live with any of these diseases, and you know what it truly entails, or you were a caregiver to someone with one of these diseases, I feel like that's the person who's most qualified to decide what makes the most sense for their child. So I think in terms of what's the line between diseases and traits, I mean, one of the maybe beneficial consequences of the insurance system is that we have these ICD-9 codes. We have all these codes for these are considered diseases, and this is what we're going to reimburse for, and these are the treatments that we're going to reimburse for. So I think that we have a really nice catalog of what we consider therapeutic versus what we consider cosmetic. And I think that perhaps for some of these conditions the lines might be blurry, but I think that it's sort of similar to the current healthcare system, right? Where it's like it's a problem if you're going to your doctor and you're trying to solve it, right? So similarly, if a parent feels like it's something that's very that could very significantly negatively impact their child's life, then I think that's something that should be considered. I mean, they're the ultimate arbiter of how their child grows up, and they're the owners of their them and their partner's genetic information. So I really think that it's about autonomy and informed choice for the parents fundamentally. I mean, our job is really just to deliver good science and to deliver good counseling, right? We're supposed to do a excellent job at calculating these risks, doing the chemistry, making sure that the scores that we're reporting we're very confident about. But at the end of the day, I mean, that is the end of the day for us, right? It's ultimately up to the couple and the clinical team to decide what actually makes the most sense for the implantation decision.
Yeah, I mean, our moral intuitions on this are pretty much in line. So, where do you see the industry going in say 5 to 10 years?
Where do I think it's going, or where would I love to see it go?
Well, both. Where do you think it's going? And, what would be the best case scenario?
Well, I definitely do think that this type of testing is going to become um, much more common, because I think that it's like I said, it's just one of the most fundamental human desires. Is I want my child to suffer less than I did, and if you can, stack the odds against disease, why would you choose not to? So I think it is just going to be a question of education. Do you know that this exists? Do you know what the costs are? Do you know how to access it? So I think that's definitely going to become more common in the future. I hope that there's going to be expanding insurance coverage, and maybe you'd be surprised to hear this, but I'd also welcome actually more regulatory involvement, because I think that there are going to be many more companies that are going to come into the space, and I think that there is the risk for parents or doctors or any someone who's receiving this technology to not really have the appropriate safeguards in place to make sure that the testing is operating at the level that it should for as consequential of a decision as this actually is. So I think that's going to happen over the next 5 to 10 years. And then I guess my wish list for things that I would love to see happen would just be, many more, like, I guess some things that we consider to be sci-fi becoming real. But basically, one of the main limitations during IVF is just the number of eggs that you can, number of eggs and embryos that you can create. And there's a lot of really interesting technology called in vitro gametogenesis and somatic cell nuclear transfer that are looking at ways to generate, eggs from stem cells, ways to transfer genetic material from somatic cells into egg cells. Like there's many different techniques that have been proposed, and many of which that have actually borne out in animal models that could be applied therapeutically in the reproductive setting. And I think that's super exciting, because then not only do you give couples the opportunity to have healthy kids, but you'll also allow women to have a much wider fertility window, right? It's like I don't think you need to talk to many women to find out that they're stressed about having to have a kid before 35 or 37 or whatever the new whatever the new window is that you want to put on when it might be healthy or more fortuitous to have a child. And I think that a lot of these technologies that are I think underfunded, underhyped, and underinvestigated, if those come to fruition, I think that women will have basically the same freedom that men do, of basically being able to have kids whenever and not have to have their biological clock ticking in the background.
Yeah. So, Noor, I know you have a meeting coming up. Is there any, is there any, are you on Twitter? Is there a place where people can find you? Do you, is there, anything, if people are interested in your work and want to keep up, how would you advise them to do so?
Yeah, so you can check out Orchid at www.orchidhealth.com, and then you can find me on Twitter at Noor_Siddiqui.
Okay, great. And I'll be very interested, when the company, starts operating full time next year, and we'll have to have you on to talk about how it's going.
Cool. All right. Thanks so much for the time. I really appreciate it, Richard.